NASA says its Explorer 1, the most distant human-made object inside the universe, is sending usable records to Earth once more. Inside the universe, we don't have any concept of what it is, except for the fact that we can gauge it. Explorer 1, the infamous space probe sent off by NASA more than 4.5 decades ago, has recently conveyed back a message that has sent shockwaves through the academic network. After traveling almost 14 billion miles from Earth, Explorer 1 has made a discovery so vast that it has changed the course of its mission, turning around toward our planet. Be a part of us in this grandiose adventure. 7 minutes ago, Explorer 1 made an alarming discovery, turning toward Earth. But what exactly might this revelation be? Could it be evidence of extraterrestrial existence, a great oddity, or something even more unfathomable? In this gripping research, we will explore these thrilling discoveries, as Explorer 1 has just made a startling revelation that caused it to suddenly turn toward Earth. Records of the Explorer twin probes suggest that if certain divine events hadn't harmonized, two of the most remarkable rockets ever sent off might never have left Earth. In this case, it was the four largest planets aligning in our planetary system around 60 years ago. These planets were slowly aligning in a way that had last occurred during Thomas Jefferson's administration in the mid-19th century. This exciting planetary arrangement went largely unnoticed until Gary Flandreau, a doctoral student in flight at the California Institute of Technology, identified its importance back in 1965, when space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was entrusted with sorting out the most efficient approach for sending a space probe to Jupiter, or even farther away to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these large planets and made an exciting discovery. In the late 1970s and mid-1980s, all four planets would align in such a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, essentially reducing travel time. Flandreau discovered that this alignment could cut the flight time from Earth to Neptune from 30 years to just 12 years. But there was a catch. This planetary alignment only occurred once every 176 years. To take advantage of this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built spacecraft to make the journey, Explorer 1 and Explorer 2. These twin spacecraft were sent on an extraordinary mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Explorer twin probes on September 5, 1977, was something truly fantastic. At an area known as Cape Canaveral in Florida, Explorer 1 embarked on its grand adventure into space, launched by a powerful rocket called Titan III Centaur. Only 15 days later, Explorer 2 was launched on August 20, 1977. Explorer 1 began its journey into the vast universe, following a shorter course. Their primary mission was to explore the gigantic gas giants in our solar system, including Jupiter and Saturn, along with their numerous moons. But these brave space voyagers surpassed all expectations. They ventured far beyond, pushing the limits of exploration, visiting farther and longer than any other spacecraft in history. They broke numerous records on their inspiring odyssey, venturing beyond anything made by humans before, even entering a region known as interstellar space, a completely unknown area within our galaxy. These exploratory spacecraft, Explorer 1 and Explorer 2, are now more than 12 billion miles from us. Despite their immense distance, they continue to astonish scientists with the groundbreaking discoveries they make. Most recently, they made a discovery so startling that it has taken everyone by surprise. The Explorer twin probes have achieved numerous truly remarkable feats. Years ago, they studied the moons of Jupiter and Saturn, surprising scientists who initially believed them to be dull and pitted like our own moon. These moons turned out to be lively hubs of interest. Explorer 1 made history by becoming the first of the twins to swing by Uranus in 1986, and just 3 years later, it zoomed past Neptune, an accomplishment unequaled by any other spacecraft. As these spacecraft continued their complex journey, NASA employed some smart strategies to ensure they remained functional. They deactivated non-essential components like extra heaters and parts to conserve power. The goal was to keep the spacecraft operational until at least 2025. For the dedicated scientists and engineers who have been part of this incredible journey from its inception, it is a mix of emotions. Their hard work has paid off, and just when they thought the Explorer missions were nearing their end, a shocking discovery emerged from the depths of space. At the start of their grand journey 40 years ago, the Explorer spacecraft surprised specialists by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily pitted like our own moon, turned out to be dynamic worlds. Explorer 1 reached Jupiter in March 1979, only 546 days after its launch. Explorer 2, following a slightly different trajectory, arrived in July of that same year. Each spacecraft was equipped with special cameras that used filters to capture full-color photographs. These cameras were designed to rotate through space at a rate more than 40 times slower than the hour hand of a clock, ensuring that the images they captured were clear and sharp. During their mission, the explorers took more than 33,000 pictures of Jupiter and its moons, each revealing new and fascinating information. For example, Europa, one of Jupiter's 53 named moons, was found to have a cracked icy surface estimated to be more than 60 miles thick. As the spacecraft departed from the Jupiter system, they received a speed boost of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that propelled them closer to interstellar space. At Saturn, the explorers went their separate ways. Explorer 1 passed through Saturn's marvelous rings, enduring thousands of impacts from tiny dust particles before flying through Titan, a moon surrounded by an orange haze, and traveling north out of the planet's rings. Explorer 2 continued its mission, reaching Uranus and Neptune in 1986. During its visit to Uranus, Explorer 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. But Explorer 2's achievements were overshadowed by tragedy struck only 4 days after its closest approach to Uranus. The Space Shuttle Challenger tragically exploded shortly after liftoff, killing all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian in space. 3 years later, as Explorer 2 flew over Neptune's beautiful, sky-blue, methane-rich atmosphere, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest places in our solar neighborhood, with surface temperatures plunging to a frigid -235 degrees Fahrenheit. The moon's frozen volcanoes were another extraordinary discovery, shooting nitrogen gas and particles as much as 5 miles into its atmosphere. After Explorer 2's captivating pictures of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging crew, intervened. Despite the mission's official end, NASA extended it with hopes that the explorers might venture into interstellar space. Renamed the Explorer Interstellar Project, the spacecraft were set to continue their journey into the unknown. Explorer 1's interstellar adventure took a stunning turn in August 2012. It reached a remarkable milestone by venturing beyond the heliosphere, a vast region of charged particles created by the Sun. This achievement became well known the following year when a study was published in the journal Science, sharing Explorer 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a strong solar flare between April 9 and May 2013. This event caused electrons near Explorer 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found within the heliosphere. At first glance, it might seem surprising that the electron density is higher in interstellar space than near the Sun. However, researchers explained that the electron density at the edge of the heliosphere is much lower than on Earth's surface. By analyzing Explorer 1's data, scientists pinpointed the spacecraft's specific flight date as August 25, 2012. This determination was based not only on electron movement, but also on measurements of charged solar particles gathered by the spacecraft on that pivotal day. For the Explorer team, this announcement was a source of great pride and excitement. Susan Dodd, the mission director, expressed the team's joy, saying, "We are pleased to have been able to keep working with the explorers and to see it achieve the remarkable milestone of entering interstellar space." Ed Stone, a key figure in the Explorer missions from the very beginning, emphasized the importance of this achievement in advancing our understanding of space. He said, "Explorer 1 has led us to new discoveries by giving us the first view of this new region, increasing our scientific knowledge of the nature of energy and radiation in space." Explorer 2 also crossed into interstellar space in November 2018, venturing into an unknown region beyond the Sun's protective bubble, which shields us from cosmic radiation. But the truly astonishing news comes from Explorer 1. After an extraordinary 46 years, NASA's Explorer 1 spacecraft, the most distant human-made object in space, continues to send valuable information back to Earth. Despite its unprecedented distance of over 14.7 billion miles, the spacecraft remains operational, although its primary mission concluded long ago. Here's where things get really interesting. Explorer 1 has recently made an incredible discovery that has left scientists both baffled and deeply concerned. As Explorer 1 traveled through space, something rare occurred. It began sending data back to NASA, revealing an anomaly in its trajectory. The data it transmitted indicated signals containing information about an unknown phenomenon that defied explanation. This anomaly appeared to suggest the presence of a huge, previously undetected object exerting a tremendous gravitational pull, distorting the spacecraft's path. This discovery has shaken the scientific community to its core, sparking a whirlwind of speculation. Could it be a rogue planet, a black hole, or something even more extraordinary? The implications are staggering. If confirmed, this newly detected object could dramatically change our fundamental understanding of the universe. NASA has assembled an emergency team of scientists to investigate further, utilizing all available resources to analyze the data and potentially redirect Explorer 1 to gather more information. This shocking twist in Explorer 1's journey serves as a reminder of the vast mysteries that lie beyond our planet and the enduring spirit of exploration that drives humanity to seek answers in the far reaches of space. The spacecraft, equipped with 3 radioisotope thermoelectric generators, had an estimated operational lifespan of 4 to 12 years. Remarkably, Explorer 1 has far exceeded expectations, continuing its mission for an astounding 45 years. Unlike solar panels, these radioisotope thermoelectric generators produce energy by harnessing the heat generated by the radioactive decay of plutonium-238. Despite this impressive perseverance, NASA estimates that by 2025, the Explorer spacecraft may no longer be able to generate enough power to operate its instruments and transmit data back to Earth. During routine communication with Explorer 1 via NASA's Deep Space Network, something extraordinary occurred. After more than 40 years of continuous data transmission, NASA's computer systems on Earth began receiving an unusual signal that left everyone concerned. For the first time in its mission, Explorer 1 suddenly halted its journey and performed a complete 180-degree turn. As the NASA team watched in astonishment, Explorer 1, which had faithfully traveled in one direction for nearly half a century, executed an inexplicable maneuver. A spacecraft with no propulsion system capable of making course corrections had somehow reversed its trajectory. Engineers and scientists scrambled to make sense of the data. Had the spacecraft encountered an unknown force? Was it responding to an external signal? Or had something, or someone, intentionally redirected it? To rule out a system's malfunction, NASA engineers meticulously analyzed Explorer 1's telemetry. The spacecraft's onboard systems appeared to be functioning normally. There was no indication of a mechanical failure, nor had it lost contact with Earth. Yet, the signal it was transmitting carried strange, indecipherable data, unlike anything previously received. A signal from the unknown. As the weeks passed, NASA's Deep Space Network continued to monitor Explorer 1's transmissions. Then, on a quiet morning at Mission Control, something extraordinary happened. A new sequence of signals emerged, structured, rhythmic, and eerily deliberate. At first, the patterns seemed random. But as scientists decoded the data, they discovered something remarkable. The signal contained a repeating sequence of prime numbers, a pattern that does not occur naturally in space. Prime numbers, numbers divisible only by 1 and themselves, are often considered a potential form of extraterrestrial communication. The realization sent shockwaves through the scientific community. Could this be evidence of intelligent life? If so, was Explorer 1 responding to an external signal, or had it been intercepted by something beyond our understanding? An urgent mission. With the world now watching, NASA assembled a top-secret task force of astrophysicists, mathematicians, and cryptographers to analyze the mysterious transmission. The discovery was too significant to be dismissed as a mere anomaly. Efforts to decipher the signal intensified. Days turned into weeks as supercomputers processed the incoming data. Then, a breakthrough. Scientists uncovered a secondary layer of information embedded within the transmission. The message was more than just numbers. It contained a series of complex waveforms, suggestive of an encoded image. Excitement turned to trepidation as NASA's computers reconstructed the image. What they saw defied belief. Projected onto their screens was a pattern resembling a star chart, an intricate map of celestial coordinates. But what truly stunned the team was the presence of a distinct symbol at its center, a shape eerily reminiscent of Explorer 1 itself. The implication was staggering. Whatever or whoever had sent this signal knew about Explorer 1. More importantly, they had been expecting it. The countdown begins. As speculation mounted, NASA faced an agonizing decision. Should they attempt to send a response? And if so, what should they say? Every possibility had to be considered. Were they about to make first contact, or had Explorer 1 inadvertently stumbled upon something that humanity was never meant to find? Then, the most chilling discovery yet, embedded deep within the star chart was a sequence resembling a countdown. But a countdown to what? With only days remaining before the sequence reached zero, the world braced for what was to come. NASA had no choice. They had to act, before time ran out.